All right, welcome everyone. So let's see, let me answer Alexander's question. Let me try to draw a picture as you're explaining that. So let's see. Okay, so you're saying angle A is on a different transversal than angle. I think I know what you're talking about, but I just want to clarify. I just want to make sure. Okay, so angle A is on a different transversal than angle B, but they are congruent. Okay, so for instance, maybe like something like here, this is angle A right here, and this is angle B right here. So they're on different transversals. I think that's what you're talking about. Right now, they are not congruent by alternate exterior angle. That is incorrect. But there's a series of things you have to do to prove that they are congruent, but they are never alternate exterior angles. Gotcha, Riley. I'll talk about that too. So, for instance, let me see where my marker is. Let's say these two top and bottom lines are parallel. So if I'm claiming that I have alternate exterior angles, well, I'm going to throw in this letter C. It's going to go right here. So angle, and so I'll write it all down. So like, let's say letter, I don't want to do A. Let's do, oops, line L and line M. So if this was a proof, okay, it's not technically a great proof because we don't have anything given, but I'm just answering one question from earlier from Alexander. Yeah, I could definitely do that too, Ryan. So let's say line L and line M are parallel by just given because it's in the picture. All right, and then so number two, all I can say using this yellow transversal, all I can say is angle A and angle C are congruent. Usually you don't write it like that, but it's okay. That's due to the fact that if two lines are parallel, then the alternate exterior angles are congruent. So in Tir's class, we just write alternate exterior angle theorem, but I think McKee and Haygood's classes, you guys write a different reason. You actually write out the theorem. So you would say if two lines, and I know you guys have different abbreviations, but two lines are parallel, then, or like you put an arrow, then the alternate exterior angles are congruent. But did that prove that A and B are congruent? No. Okay. So we would need more information such as line J and line K are parallel. So let's say that was also given. So J is parallel to K. Then I can say, what is this? Angle C and angle B are now congruent because they're corresponding angles. This is a different picture. This is a different scenario. This is the transversal M that we're talking about. So angle C and angle B are congruent from this given. So number three, angle C is congruent to angle B. And I'm running out of space. The reason for that would be that for Tir's class, it would be corresponding angle theorem, right? Parallel lines to congruent angles. I guess I'll have to write this. 3 would be corresponding angle theorem. And if you're in McKee or Haygood's class, you would write down if, two lines are parallel, then CA are congruent, right? And then finally, step 4, I don't have room, step 4, you would say that angle A and angle B are congruent because of substitution or transitive property. So once again, that was just a quick explanation to Alexander's. Hopefully that answered your question, Alex. So the original question, your answer was no, they are not congruent by A alternate exterior angles. Okay, so now let me look at some questions. So I'm going to go over converse. I'm going to go over 17 from the homework and then number 10. Okay. I don't know why this notepad is very sensitive. It keeps pushing a button. Our substitute, Alexander, substitution and transitive most of the time, I would say like 90% of the time. This is when you would not use substitution. Sorry, I'm going off track a little bit. So let's say you have measure of angle 1, measure of angle 2 is equal to 180. Let's say that's given. I'm going to show you when it's not allowed to use transitive. And let's say measure of angle 1 is 80 degrees. That's also given. So if I say step 3, sorry, I'm not numbering it, 80 plus measure of angle 2 equals 180, I will not use transitive property here. That is not allowed. You have to use substitution in this case. Because what we did was we replaced this angle M, measure of angle 1, with 80 degrees and kept everything the same. So again, this step 3 would not be transitive. It has to be substitution. I tell my students substitution will work every time, but transitive doesn't. So better bet is to probably use substitution, in my opinion. So yes, okay. So, right. Can you do two-step proof supplementary angles? All right, okie dokie. So let's first answer the converse, okay? So when to use converse. I believe there was one question on your group quiz. And so you have to be given some information. Your hypothesis is, right after the if. So that means you have to be given, for instance, I gotta draw a picture. Here's 1 and here's 2, okay? So let's claim angle 1 is congruent to angle 2. It's given information. So I'll do like a short two-step process, statement reason. Then number 2, we can claim that line A and line B are parallel. So it has to go in this order. So the corresponding angles are congruent, or alternate interior angles are congruent, or alternate exterior angles are congruent, or same side interior angles are supplementary. Any of those 4 has to go first. Then you can claim the lines are parallel. In this case, you would say converse of AEA theorem. Now, some of the students will have to write AEA are congruent, then lines are parallel, something like that. Sorry, with a quick shorthand, okay? Yeah, I'll do 6 and several other. Okay, so here's another example for converse. So I think this was a popular one. I don't remember what number this was. Let me look at my quiz first. This one was number 7A and 7B from the quiz. This will answer, when do you use converse? You were given angle 5 is congruent to angle 7. That was given. And here's the picture, 5 and, oh, I'm sorry, this is 5 and 11. That doesn't look right. 5 and 11. Boom and boom. Sorry, right here and right here, okay? So we don't know about the lines, but now we can say that this is your hypothesis. So your conclusion is that the 2 lines, this is S and T, are parallel. And so it's kind of like going this way, right? So given angles are congruent, then the lines are parallel. And then it asks, what's the reason for 7B? And since you're proving the lines are parallel, that's when you say converse of, since these angles are alternate interior, you say AIA theorem. That's what Tira does, and I think that's what Bratcher does. I'm not sure what Mr. McKee and Mr. Haygood's notation or answer would be here. Maybe you would say, you would write it out. I'm not sure. Maybe it's like AIA angles are congruent, therefore the lines are parallel. So maybe they don't ask you to write the word converse, I don't know, or maybe they do. So maybe anyone who has McKee or Hey Good could let me know if you have to write the word converse or you have to write the sentence out. Okay, so there's a lot of people asking questions. I hope you guys can answer each other's. There's a lot of chatting. So I'm going to have to go back and see what other question there was. I think there was a homework problem. So I think the last question was on the group quiz. I could definitely do that, Nicole. Group proof. Yep, I'll do the proof and then 17. Okay, so let me do the quiz. It was the proof problem, and this is number 14. So there's a lot in the picture, and really what's important is you have to associate what you learned this chapter, which is parallel lines. So that's what you want to use in this situation. B, F, A, E. Oops. Let's see if I could put in some numbers. 3, 1, 2, 4. Oops. Okay, hold on. Okay, so I'm going to start typing if possible. That'll be a little bit easier. So number 1, we're given a lot of information. So BE bisects, you can't see this yet, angle DBA, and then angle 3. I can't do the congruent symbol, sorry guys, on my computer, so you're going to have to make do with the equal sign. Angle 2 is congruent to angle 4. And this is given. Okay, so this is given. What you need to do is say to yourself, what can I do with one of the givens? So one thing at a time. The very first thing that says is bisects the angle. So right here, you have to get rid of the clutter and you have to think, either redraw it if you need to, or just think in your head, here's the picture, here's the figure, DBA and BE cuts it in half. Now there's numbers in there on purpose to tell you to use them. So here's 1 and 2. That means using that picture and using this given right here that's boxed, I can say angle 1 is now congruent to angle 2. And that's saying definition of angle bisector. Okay, so now I use that one. I'm probably not going to use it again. You usually use one of the givens once and then you're done with it. So now number 3 was kind of guided. It had like blanks. So I had angle, congruent to angle, and then another one. So if you look at 1 and 2 and look at 3 and 1, well, don't they both have a 1? So that means that 3 is congruent to 2, or vice versa. So using the other given that I boxed in black and the second step green, that's going to be 3 is congruent to 2. That's either transitive property or substitution. Substitution. Sorry, I can't make the full word. Okay, but now there's one last given. So I'm going to highlight this one in gray. So using angle 2 is congruent to angle 4, and this other one right here, can't we get rid of the 2's, right? So that means the 2 gets replaced, and we have angle 1 is congruent to angle 4. Okay, now the goal is you want to look at your picture. At this point, you're like 2 more steps away. Usually the second to last step is the hardest to figure out, right? You're like, I got the middle, or the second step, but I don't know the middle step. So you look back and say, what do I want to prove? Because at this point, I don't know, like where to go. So you say, oh, I need to prove lines are parallel, which probably means you want to state something about converse. So now I'm going to look at my picture and I'm going to see if I could delete this angle BE stuff because we've already done with that. Okay, so I'm now gonna look at, this is all about parallel lines, and I'm gonna try to highlight it to make it pop at you a little bit. Notice, I'm pretty sure these green lines are gonna be parallel. Like you have to think ahead, think this chapter is all about parallel. So that means if I redraw 3 and 2 only, like now I'm gonna try to use this, right? So if I redraw CD, the green line, and BE, the other green segment, and then I have a transversal that touches 3 and 2. The transversal is CA. So I'm going to try to draw that best of my ability. So I have C, D, B, E, and then this is A, right? So then I know I need to use 3 and 2. Well, here's angle 3, here's angle 2, and we're saying they're congruent. Oh, what? What kind of angles are those? Those are corresponding angles. So that means we are at the point where this right here, step 3, is saying corresponding angles are congruent. Then what can you say? Then lines are parallel. What lines? The green ones. So we can say, or sorry, segments. Segment CD is parallel to segment BE from angle 3 and angle 2 being congruent. And this is where I think Ryan asked and Nicole asked, several other of you guys asked, when do you use a converse? It's when you're trying to prove lines to be parallel. Well, first of all, what kind of angles were 3 and 2? They were corresponding. Corresponding angles are congruent, therefore lines are parallel. That's always converse. Okay, so then we still have one more thing that we didn't even look at. We didn't look at 1 and 4. So you would want to redraw, like declutter all the stuff, from the original figure and look at angle 1 and 4. So I'm just deleting a couple things so that I could redraw. Now, do you have to draw these out? No, but I highly recommend it if you can't picture it in your head. So now I'm going to draw angle 1 and angle 4. Let's see, here's angle 1 and angle 4. And I know I'm going to probably use the green lines, right? Here's BE and here's FA because they touch angle 1 and angle 4. And then I'm going to draw this other transversal FD. Okay, so then take a look, angle 1 and angle 4 in here. So we're at this point. We didn't use this yet. So angle 1 is congruent to angle 4. That means two lines are parallel by the converse. Okay, so that means BE is parallel to FA. Again, same reason, number 4, so you don't have to write it twice. From there, now we are, you got to look at step 4 to step 5. Notice both of them have a BE. So that means you could use transitive property of parallel lines. It depends on what your teacher asked you guys to do. This was from chapter 3.4, that last step. I'm okay with transitive property. Some people use substitution. It's technically sort of, it's correct. So yeah, alrighty. Now let me answer a couple other questions. So I know there was some from homework and some from the quiz. So let's see. And if I don't answer your question, you can restate it. I'm just scrolling up a little bit. So 17 from the homework, number 10 and 6 from the quiz. Okay. And then some proofs. Okay, so for sure 6 and 10 from the quiz, and then 17 and okay. All right, so I have this so far. I have quiz number 6 and 10, and then homework number 17, 23, 41. Oops, I see quiz 11. Okay, if I missed it, I'll come back to it. Okay, and 2 proofs, 2 column proofs. Okay, so quiz, I'll do 6, 10, and 11. And then I'll do the book work. Okay, so number 6, that one. Okay. This is because it was bold, hopefully, on your quiz. It said, if S and T are parallel by the alternate interior angle theorem, you must use that because this was bold, then what angles can be congruent. So you don't want to use any vertical angle theorem. You don't want to use any other stuff that has nothing to do with that. Okay, so let's see. 7 and 9, these are parallel. So that means angle 7 and angle 9 are congruent. This was letter C. That was the final answer. So this is true. And then another picture we had was 6 and 12. So here's 6 and 12. It's using a different transversal. These are alternate interior angles, so D was correct. Now, the reason why the other ones weren't correct is because it didn't go by what was bold. So even though if you thought A was true, I mean, yeah, 1 and 7 were congruent, but it had nothing to do with the alternate interior angle theorem. So you had to use that. So yes, 1 and 7 are congruent, but not by this theorem. So therefore, that was not part of the answer. Okay, so again, let me clarify. Angle 1 is congruent to angle 2, but that's because of vertical angle theorem, not because of this. So that's why that was out. Letter B was out because 1 and 5, I mean, there were not even parallel lines like A and B. So B was completely out. And then letter E was wrong. Let me see if I can go back to E. I'm going to draw it out. E was wrong because, let me see, where's 10 and 14? Here's 10 and here's 14. So yes, these are alternate interior angles, but no, they are not congruent. And that's because these lines are not parallel. So unfortunately, letter E was incorrect. 10 and 14, they are alternate interior angles, but they are not congruent because these lines are not parallel. So if they're not parallel, nothing happens. There's a name for it, but they're not congruent. Okay, I'll also do number 4. Let's see. So yeah, Mr. McKee is correct. A is correct, but I mean, at least for my class, I wanted them to read the question and say, based off of the alternate interior angles, those aren't true. Okay. All right. What was the other number? I did 6. Next was 10, and then I thought I saw another question, but I don't know where it went. Oh, 4. So 10, 11, 4. So number 10 from the quiz is on the back. Ooh, this was a good one. Okay, so I'm going to read it and write it as we go. It said the largest angle, oh, by the way, choose the smallest to be x. So the largest angle is, so, equal sign, 4 times the smallest, so 4x. So I have the smallest, I have the largest. Now we just need the third angle. It said, and 27 more than the third angle. So what is it? So again, it's the largest, that's your noun, angle is 27 more than the third. Ooh, well, that's a bummer because you don't have the third. So my recommendation is solve for the third. So subtract 27 from both sides. And now you have the third angle is equal to the largest minus 27. By the way, you know what the largest is. So the third angle is 4x minus 27. Boom! Now we have 3 algebra expressions, and we're going to use those expressions to create an equation. So that means I have x plus 4x plus 4x plus minus 27. Okay, I'm going to use all these 3 green ones. I'm going to go to the next page. So I would do x plus 4x plus, the third angle was 4x minus 27 equals to 180. So you combine like terms, and you get x is equal to 23, I believe. And then it only asks you to solve for the largest Now on the test, it might ask you to plug everything back in, like find the smallest, find the medium, find the largest. So this one, the largest is 4 times x. You plug in the 23 and you get 92 degrees. Now if it said find all of them, you would have the smallest is 23 degrees. The third angle is 4 times 23 minus 27. And that will be 65, I think. 85. Yep. So those are your 3 answers. Now, on the quiz, it only asks for the largest. Okay. So that was number 10, then 11, and then 4. Okay. So number 11 from the quiz is a graphing one. Okay. So it said write an equation of a line that is perpendicular to y equals negative x, and it passes through 5, 2. There's different ways of approaching this. I call it method 1, method 2 in my class. So step 1, you have to say something about this. So currently, the slope is negative 1. But if you want something to be perpendicular, you have to use the opposite reciprocal, meaning you want to use positive 1. Again, you want to use the opposite reciprocal of what you're given. So this is what you want to use, m equals 1, and this point is what you want to use. Okay, so now I don't care about anything else. I'm just looking at the red ones. So then from that, we have a couple choices, 5, 2, and then 1. Okay, so I have 5, 2, and then m equals 1. So method 1 is some people like to put it in point slope form first. And then, you plug all these 3 numbers in to 1, 2, 3, and then you figure out the slope intercept form. So this will be y minus, this is y1, and then m is 1, x is x, and 5 is x1. And then you just distribute the 1, and then add the 2, and then you get your answer. So y equals 1x minus 3, final answer. Okay, that's method 1. I'll show you method 2. So I'm not really reading the chat box right now. Sorry, guys. I'll come back to that. So method 2 is you get the same answer, okay? You go straight into y equals mx plus b, the goal, and you're going to plug in 2 for y, 1 for m, and 5 for x, but we're trying to find b. We're trying to solve for it. So that means we have to subtract 5 from both sides, and we'll get b equals to negative 3, which means we found the y-intercept. So our final answer will be slope 1x, or 1 is a slope, then put an x after, and then the y-intercept, which is negative 3. Same exact answer, just different styles, different methods. Okay, then that was number 11, and then part B, you had to graph it. So, okay, part A, the answer was y equals negative x. Part B, oh, sorry. Erase. It was x minus 3, that's what we just found. 1x minus 3, and then part B, it's a graph y equals negative x and y equals 1x minus 3. So let's graph the first one. The y-intercept is 0 because it's like technically plus 0. So you start at 0, 0. And then since the slope is negative 1 over 1, you go down 1 over 1, down 1 over 1, down 1 over 1, and then or up 1, left 1, up 1, left 1. So you connect it, and here is your graph. Okay, so that's y equals negative x. Y-intercept is 0. Then, and tomorrow, hopefully you label it line 1. Then line 2, you start at negative 3 on your y-intercept. So negative 1, negative 2, negative 3. You put your dot there. And then you go up 1 over 1, put a dot. Up 1 over 1, put a dot. Up 1 over 1, put a dot. And then you connect that one, or down 1 to the left 1. And then you label that one line 2. And it's not asking you to figure out what's the answer or anything like that. That will be just your two graphs, okay? And make sure they are perpendicular, right? That's the goal. They look pretty perpendicular to me. They look 90 degrees, so we're good to go, okay? The next question was number 4 from the quiz. So I think what we've done so far on the quiz, if you're just kind of coming in, is we've done 11, 14, 10. We've already done. And then I'm going to do, we've done number 6. And we'll do number 4. Okay. So quiz, and then I'll go answer the questions from the homework. So quiz 4, and then some proofs. Okay, we definitely want to practice proofs. Angle 5 and 13 from the picture. These are parallel. 5 is here. 13 is here. So for number 4A, it said name the angles. So 5 and 13 are corresponding angles. Then letter B said solve for X and Y. So we were given measure of angle 5 equals x squared, and measure of angle 13 equals 3x plus 18. And then measure of angle 14 we'll do after. So because their lines are parallel, that means the angles are congruent by the corresponding angle theorem. So my math is they're equal to each other because they're congruent means equal. And then whenever you have a x squared is quadratic, you want to move everything over to the other side. So subtract 3x, subtract 18, set it equal to 0. This is factorable. So you think what two numbers multiply to negative 18? I think 6 and 3. One of them's negative, and what adds to negative 3? Well, that means it has to be negative 6, positive 3. Now you're still solving, so make sure you set each to 0 and solve. So if you add 6 to both sides, you get 6. And subtract 3 from both sides, you get negative 3. That's easy, hopefully, if you know how to factor. So from there, it said find y. Well, y was right next to here, next to 14. It said measure of angle 14 equals y. Correct. I'm going to plug it in. So if you look at 14 and 13, those are a linear pair. So you have to do a little bit of calculation. So we got 6 and 3. Okay, let me redraw. So you have 14 and you have 13. This is y, and this was, what was it? 3x plus 18. So when x equals to 6, that was one answer. We have to kind of think about, here's y. Let's plug 6 back in here. So that's 18 plus 18, 36 degrees. And again, linear pairs, so you have to add those two equal to 180. And the leftover looks like 144. That means your ordered pair is 6, 144. That's one ordered pair, one answer. There's one more answer because that's what it says, ordered pairs. There's two answers. Okay, perfect. Thank you, guys. So then the next one was x equals negative 3. Here's your y, and here's your 3x plus 18. So if you plug in into here, that's negative 9 plus 18. That's 9 degrees. Y is here. Linear pair. Oh, this is humongous. Y is equal to 171. So that means your ordered pair is negative 3, 171. So two final answers. So 6, 144 and negative 3, 171. Okay. I think I answered everyone's quiz question. If I didn't, please put in the chat box again. I'm going to go to the homework questions. So I kind of forgot what the numbers were already, so I have to go back. Homework questions. Let's see. Yes, where did I? Let's see. Okay, I don't know what happened. All right. We already did 10, 15, and 23 on the homework. Okay. So if I already kind of lost it, so you have to tell me again. 15 and 23. I know there was more on the homework. Sorry if I missed it, so you'll have to retype it again. 15 and 23. Let me go back. 15. And we'll do some proofs. I'm going to start doing the proofs around 7:45, so I'm going to spend 9 minutes on the homework questions. So number 15 and then 41, gotcha, is, okay. You have a lot of lines going on. I'll draw this one a different color. Here to here. Nice. Okay. I think they said 2 lines are parallel. There were these markings. And there's a bunch of angles. So 1, 1, 8, and X. So let's ignore that green segment. If you ignore that green segment, boom, bye, then what kind of angles are these, right? These angles are, I think, corresponding angles. So that means if the lines are parallel, the corresponding angles are congruent. Therefore, X is equal to 118. So you have to erase that in your head, right? Erase that blue, green line. Okay, then, perfect. 37. There was more stuff. There's a Y and a 25. So Y, and 25. Now you have to, in your head, erase this other parallel line by, it's gone, erase this by, erase X by, and let's look at just this line. So this line is formed from 3 angles. So it's like not a pair, but a triple. So this line has 3 angles, and this all should add up to 180. Therefore, you do 118 plus y plus 25 equals to 180, and then you'll get your answer. Okay? So you got to look at it one thing at a time. How do you turn standard form to slope? Ooh, good question. Okay. Thanks, Ryan, for doing that. Okay. So then the next one, oh gosh, I already forgot the number. I just did 15. Now 23, 37, 41. 23, 37, 41, homework. Okay. So from here, if I do 23 from the homework, let me see how many times. Okay, we have 8 minutes for the homework, and I'll do the proofs. So 23, where's 23? Okay. So there's a picture. I'm going to have to try to draw. A, B, C, D. So there's only one symbol right here. And it's saying if C is parallel to D, so let's mark it. These are parallel. That means, let's not even answer the question that it's saying right now. That means this angle here and this angle here have to be 90 because they're corresponding angles due to the fact that they're parallel. Also, these are alternate interior angles, so that would have to be 90. And, so these are all a bunch of 90 degrees if you haven't noticed already. So it does say what's the conclusion, then what's perpendicular to angle or line C is it has to be line A, right? Notice line A is now a bunch of perpendiculars. So line C and line A are now perpendicular. Okay, I think that's one of the theorems from notes 3.4. So you can check out the book 3.4 or your notes 3.4. Why can't it be B? Because B doesn't touch the line B is not touching the original angle that they gave us. So let me redraw what they had. Here's the original picture from the book. So line B is not touching that angle, so therefore it has nothing to do with it. I hope that makes sense, Max. Okay. So all I can do is use this transversal. Does that make sense? Line A only. Okay. All right. Let's see. I did 23. So 3741. Okay. 3741 and any other homeworks. Sarah, I think there is a 90 degree on your book. Check it out. Okay. All right. So then 37 from the homework is, oops, next page, slope. Ah, okay. So, and I'm going to do the standard form to slope-intercept too, if I can. Negative 2x plus 5. Name the slope and the point, and then graph. Okay, so this is called point slope form. Basically, it's in this format. That's an M. So here's the flaw about your original is that, oops, this is what I went. After the x, it should have been negative. So in other words, it's like that, negative 5. So it's easy to extract information. X1 is after the negative sign. So x1 is negative 3. Y1 is after the negative sign. So it's positive 3. And then your slope is in front of the parenthesis m, in front of parenthesis x. So slope is negative 2. Is this 37? Yeah, this is 37 from the homework. So then it's asking name the slope. Here it is, negative 2. And the point, negative 3, 3. Okay. All right. So how do you graph it? Oops, let me go back. Did I copy this? Oh, I copied it wrong. I'm sorry, that's a 5. I didn't read my writing right. This is a 5. This is a 5. So 5, negative 3, just like Matt said, Matt Nguyen. So then if I were to graph it, I would graph negative 5, 3. Put a dot there. So 1, 2, 3, 4, 5. 1, 2, 3. So here's negative 5, comma. Oh, no, it's up here. 1, 2, 3. I just caught myself right here. This is where you put your dot. And then the slope was negative 2. You could always make it a fraction. So you're going to go down 2 and over 1. So go down 2 and then over 1. And then you have your next dot right here. And then do it again. Go down 2 and then over 1. You have your next dot. So the slope is negative. So you better be declining. You better be decreasing. And then just make it long enough and put arrows. So there's your graph. Now, if you're not comfortable graphing that way, there's a last option. Remember, this was your equation, right? So you can convert this to slope-intercept form. You can distribute. So you're like, I don't like graphing like that. Then here's another way. So you distribute the right side, and then you add 3 to both sides. And then you'll get y equals negative 2x. That's a 3 minus 7. This is in slope-intercept form. So in other words, you go down 7, pretty close, my graph. And then you go down 2 over 1, down 2 over 1. If you run out, you could go up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. And you get the same graph. So if you're not comfortable, okay? The last homework question was 41 that I saw, unless I skipped one of them. Oops. And then I will go over standard form to slope-intercept. 41. This one, I'm not going to finish the whole thing. I know this was on your quiz, similar to your quiz. So A is negative 1, negative 4. And then B is 2, 11. C is 1, 1, and 4, D is 4, 10. It's asking, what do you notice about line AB and line CD? So you need to find slope. And to find slope, you always subtract the y's and then over the x's. So if I'm going to do that for the AB, the slope of line AB, you could always graph it if you're not comfortable doing the calculation. You take y minus y, so that becomes a plus, right? 11 minus 4. And then the bottom is 2 minus 1. Again, becomes a plus. So the slope is 15 over 3, which is just 5. The slope is 5m. Okay, that's for the first one. Then you do it again for CD. So this is 10 minus 1. So 10 minus 1. And then the bottom is 4 minus 1. So that's and that'll be 9 over 3, and that's 3. So that means, wow, 3 and 5, they are not the same. So this is not parallel. 5 and 3 are not opposite reciprocals, so it's not perpendicular. So therefore, your answer to this question is neither. Again, it's because your slope was 5 and your slope was 3. That's why it's neither. Okay, they're not the same and they're not opposite reciprocal. Yep, okay. Feel free to graph it if you're not comfortable finding the slope using slope formula. All right, so then yes, it is like number 12 on the quiz, I believe. So number 12, the intention was to have you guys find the slope of all 4 sides and then compare and contrast. Like, are there any parallel? Are there any same slopes? No, so then no parallel lines. Here's the question. I don't remember who asked it anymore. I kind of had to scroll up. Was about standard form, which you're not required to, write it out, to slope-intercept form. In other words, you have like 3x plus 4y equals to 24. So step 1, you need y by itself, right? That's the goal. So then you're going to get rid of the 3x and just move it to the other side. So then now you have 4y on the left equals, I like to put the x first and then the number after. So this is your new equation, not the final answer, but the new equation. And then now you're like, I have to get rid of the 4, so I got to divide everything. Oh boy. So now you're done. You have negative 3 over 4 as your slope and 6 as your y-intercept. Yeah. So therefore, this is now your slope-intercept form, and your slope is negative 3 over 4. Okay, the reason why you want to know how to do this is because, let me go back, let me write it a little smaller. So it's going to have a question like this. It'll say, here's one equation, and I'll write another equation. Okay, that's a 3, sorry. So remember this answer was, what was it? Let me go back. Negative 3 over 4 x plus 6. That was the answer to the first one, and this is another line. Let's just say you're given 2 lines. The question will say, is it parallel, is it perpendicular, or is it neither? And you would say, oh, because the slope here is negative 3 over 4, and oh, because the slope here is 3 over 4, what do you notice? Are they the same? Nope. So that means it's not parallel. Are they opposite reciprocal? So are they opposite signs? Yes. But are they reciprocal? No. So it's not perpendicular. So exactly, your answer is neither in this case. So it's very useful to be able to do the algebra to solve for y, to get the y alone so that you know what the slope is. Okay? Yep, the negative does. All right. Okay. Oh, we passed it. So now I'm going to go to proof. So it's 7:48. I am going to do a few proof examples. Again, if you practice your quiz, you should be pretty good. And what I want to do right now is I want you to look at this. I did this maybe once with my students. I'm going to give you a wrong answer, okay? And I want you to, oh yeah, definitional supplementary and SSIA is different. How do I say this fast? Okay, Gina. So SSIA angles, you have to have parallel lines, and then those are now SSIA. So in this picture, angle 1, angle 2, 180, it's because the lines were parallel. So now we can say SSIA, okay? Versus, when do you use definition of supplementary? That's when you have, for instance, angle 5 and angle 6 are supplementary. That's given. And then you write measure of angle 5 plus measure of angle 6 equals to 180. And even in your picture, it might be something like this. It's not SSIA. Like look at your picture, right? Or linear pair, exactly. So SSIA, you have to have lines are parallel, then you can state the fact, okay? But without lines parallel, we can't say anything about those SSIA. All right, so here's a common mistake. I'm gonna draw it out. And one of the answers is wrong. And it's only three steps. So you have to observe what's happening. And then after this, I'm going to hope to get through a couple proofs. These are parallel, just the G and H. Here's angle 1, angle 2, angle 3, angle 4, angle 5. So all we know is G and H are parallel. That's given. Here's number 1. And number 2, angle 2 is claiming to be congruent to angle 1 by alternate interior angle theorem. And number 3, we're going to claim 2 and 5 are congruent, AIA theorem. So one of them is wrong. And it's because we don't have enough information. So is number 2 wrong or is number 3 wrong? And the answer is number 2 is wrong. Okay, yeah, and number 3 is wrong. I said it wrong. I was looking at 3, but I looked at, yep, this one is wrong. Very good. That one is wrong because we never stated the fact that line P and R are parallel. So look at how the red and the yellow, right? Red is the transversal. So we never said the 2 yellow lines are parallel. We never said P and R are parallel. It was never stated. So that's why 2 and 5 we cannot say. Okay, versus if you look at G and H, those are parallel, and we have our transversal touching 1 and 2. So yes, that is correct. That's a big mistake. Okay. All right. So now let's do a full-on proof. I'm gonna pick one from my bag of tricks. Let's see. Okay. So just again, make sure you know when to use converse versus when to use no converse, okay? So here is our proof, only 4 steps. And here we go. So I'll just write down the given. I'll draw the picture. 1, G and H are parallel, and angle 1 is congruent to angle 2. Those are both given. So you can't do anything without a picture, so here's the picture. Here's P, here's R, G, and H. So we are given G and H are parallel. Oh, I don't have numbers, sorry. And here's 1, 3, 2. 1, 3, 2. Okay. Our goal, sorry, number 4 is to say P and R are parallel. Okay, so let's use the fact that 2 lines are parallel. Let's look at those 2 lines and let's look at one transversal that touches 2 angles. So I'm hoping you're looking at line P. So from that picture, we can say, hey, 1 and 3 are corresponding angles. And now those are congruent because the lines are parallel. So if the lines are parallel, we can say the corresponding angles are congruent. So I know McKee and Haygood, you would write lines parallel, therefore corresponding angles are congruent. My students would just write CA theorem. Okay, same thing, same exact thing. It's just Haygood and McKee is just stating what it actually is. So then now you're like, well, what can I do? Well, so I didn't use the other given. So now I'm going to use the other given, 1 and 2, and use 1 and 3 and say, I can say something about that. I can say angle 2 is congruent to angle 3. Yes, right? So this is either transitive property or substitution. So transitive, POC or substitution. Both works, right, in this case. So then Now, if you look at, so like it's ignore everything. These are all done. Now just look from step 3 to step 4. Look at the picture as well. So you might need a redraw. So we're trying to claim P and R are parallel. Here is 3 and here's 2. This is from the picture and here's what's number 3. So what kind of angles are they? They are alternate exterior angles. We're claiming if alternate exterior angles are congruent, then the lines are parallel, and that's a specific theorem. And for Tiers class, you would write converse of alternate exterior angles. I'm pretty sure Bratcher's class does that too. Okay, right on. Okay, so that's where you would use the difference between converse versus no converse. So converse, you're going to have parallel lines. You're proving parallel lines. But that's only if you're given some angles are congruent or supplementary. Yep, angle 3 is an exterior angle. That is accurate. Angle 3 is outside of the two parallel potential lines. So 3 is yes, exterior. Okay? All right, so here, 3 and 2, yes, exterior. These are interior. Okay, all right, so then, let's see, let's try another one. This one's a good one. This one, my answer, I think it was Andrew Baldwin. He asked about like supplementary and stuff, so this might be a good one. This one you can go so many directions, and at least this was number 11 on the classwork that I gave for my students, that packet that was due last week. Number 11 was a big common mistake. This is all given, and then this will be done in potentially 4 steps, but this could go in so many directions. So here's P again, here's R again, here's G again, here's H again. And then before we end the session, because we're going to probably end soon, I'm going to give you a couple more things. Okay, number 1, 2, 3, 4. Okay, so step 1, let's use the fact that G and H are parallel. So now if G and H are parallel, we have to look for a transversal that has a lot of angles, and that's transversal P. So that has number 2, and number 1 and number 3. Well, I think number 1 and number 2 have a special relationship. So again, I'm using the first given right here. And so that means angle 1 is congruent to angle 2. So McKee and Haygood, you would say lines parallel, then alternate interior angles are congruent. Tiers class, you would say AIA theorem. Okay, that's step 2. Then notice that our goal is to say lines P and R are parallel. So we're probably going to have to use a converse. I already know that most likely when you're trying to prove parallel, you're converse of something. So I have to say, well, what can I use my other given, these two? What if I substitute angle 2 here, right? So then that means angle 2 instead of 1, so 1's gone, angle 2 and angle 4 are supplementary. And that's substitution. Now I have to look at step 3 to step 4, and I have to look at the picture. I have to determine why is this, or what kind of converse is this? So let me see, 2 and 4. I'm going to try to redraw 2 and 4. This could be done in different ways, once again, but this is just one tactic. So here's G, here's H. Where was 2? 2 is here, and 4 is here. And here's P and R. We're trying to claim P and R are parallel. Well, if, oh, I drew it wrong. I'm sorry. if I have 2 and 4, they're on the same side of the transversal and they're interior, they're called same side interior angles. Yeah. So then now that we're saying they're equal to 180, this is the converse of SSIA. Correct. If you're in Haygood or McKee, you might write down, if SSIA are supplementary, then the lines are parallel. But for Tier-Tier's class, and most likely Bratch's class, you'll write converse of SSIA. Okay, same side. There is Audrey, but we don't use it. It does exist, but we don't use it. 2 and angle 4 both equal to 90 degrees, right? We don't know that for sure, because angle 2 could be like 80 and 100. Like, we don't really know for sure. Okay, so one more thing I want to talk about is nothing to do with proof. It has to do with just this picture. So let's draw here. And let me draw another transversal. This was on, I think, section 3.1, your homework. If you go back, I would recommend to do a couple practice problems. Let me see what page this was, because I think this might help you for tomorrow. Like one question. Let me see. On your homework, so you were exposed to it, but it has nothing to do with parallel. This was page 144. I just drew it backwards. And this is number 17 through 20. If you have a chance to look at that before tomorrow, that'd be good. Again, I drew it the opposite way. Sorry, guys. I'll just flip everything. C, B, A, D, E. So let's try to copy the numbers. I think this will be 7, 8. I don't think I need everything, so I'll try my best to just draw what I think we need. So for instance, number 17, let's use transversal B. Let's create corresponding angles. They don't have to be congruent, just corresponding angles using transversal B. And where our goal is to figure out what lines made the corresponding angles and what angles made the corresponding angles. So this is number 17 from page 144. So we're looking for corresponding angles. This one's actually kind of easy. So we don't even need, how do I delete this? We don't even need this line in the middle, that line C, okay? So we have to use transversal B. That is a requirement. So if, wait, did I say B? I meant D. I'm sorry, transversal D. Transversal D. Sorry. Transversal D. So we have to use this line. Well, look at how many angles touch it. 8, 7, 3, 4, 6. So then now I have to find 2 other lines. Well, you only have 2 choices now because I told you don't look at C. So we're going to have to say line B and line A. And then now what 2 angles will form corresponding angles? And those 2 angles have to be in the same spot. So if you notice, there's 4 spots here. I have angle 6 in the bottom right corner, left corner. And then over here in the other lines, I have angle 7. So these are considered corresponding angles. They're not congruent because we don't know anything about parallel. And the lines are A and B. SSIA are not congruent. That's correct. They're always supplementary. Alrighty. So again, look over your quiz. Look over page 144, number 17 to 20. You could check the back of the book for some of the odd answers to get practice. But otherwise, good luck, guys, tomorrow. Tomorrow's your test. Your project is due this week as well. So yeah, there you go. All right, have a good rest of your night. Practice your proofs and see you later. Bye-bye.